Here, as I have written, that it is the assumptions made in air standard cycle, that is before we are deriving some of the cycles which are there for IC engines, we have to make some assumptions, and it is called as air standard cycle because air is used as a working fluid. So the first point, I'll write it down, that assumptions made in air standard cycle. The first point is air is used as a working fluid. Now, in case of engines, as we know, there will be mixture of air and fuel inside the engine, but here in case of air standard cycles, our assumption is only air is present inside the engine, that is air is used as a working fluid. That is the first point, because if we compare the quantity of air and fuel inside the engine, there is more amount of air compared to the amount of fuel. So we can say that air is used as a working fluid in case of air standard cycles. Next, the air used is a perfect gas, that is it obeys all the gas laws. So the air which we are using for air standard cycles, it should be a perfect gas, and perfect gas, the meaning is it should follow all the gas laws. So here air which we are taking as a working fluid, it should follow all the gas laws to be called as a perfect gas. Next, here the third point is no chemical reaction takes place. That is, the chemical composition of air does not change, it is constant throughout the processes. Then we have specific heats, that is specific heat at constant pressure and specific heat at constant volume do not change with respect to temperature. So as we know that in case of a perfect gas, or here as we are seeing air, it will have two specific heat values, specific heat at constant pressure and specific heat at constant volume, and the assumption is with the increase or decrease in temperature, there is no change in the specific heat values. Specific heat will remain constant throughout. But if we see in actual practice, as the temperature increases, there is change in the specific heat. So here this is the assumption that the specific heat remains constant, because before deriving the formula for various kind of air standard cycles, we need to assume some points. So here are the points which we are assuming. Next, the mass flow rate of air remains constant throughout the cycle. That is, no loss of air is present. It means that when a certain amount of air has been brought into the engine cylinder, that quantity of air will remain same throughout until the process is completed. That is, there is no loss of air. The air which is there inside the engine, it won't leak outside. That is the assumption. But when we see in case of actual engines, there are chances of the air to leak out from the engine or move out of the engine through the valves. So here is the assumption. So here we have seen various kinds of assumptions which are made in case of air standard cycles. because here we are using air as a working fluid, and then the air used is a perfect gas, that is it obeys all the gas laws. No chemical reaction would be taking place. Then specific heats, that is specific heat at constant pressure and specific heat at constant volume, they won't change with respect to temperature. And at last the mass flow rate of air remains constant throughout the cycle, that is no loss of air is present. Then by the term cycle we can say that cycle means that after the completion of all the processes, the system comes back to its original state or condition. That is, by the word cycle we means that when all the processes are completed, the system will return back to its original state, that is where it had started. And the processes which take place in the cycle are assumed to be reversible processes. That is, the processes which we are using in case of air standard cycles, those processes are reversible processes, that is they would be returning back to their original condition without change in their properties. And here we can say that air standard cycles are ideal cycles which are used as a standard to compare with actual engines. So air standard cycles are ideal cycles, that is they are standard which are used to compare them with actual engine, that is to check the performance of actual engines. Air standard efficiency are used. So if we want to compare the performance of actual engine with respect to the theoretical engine, we would be using the air standard efficiencies. So in this video we have seen the assumptions made in air standard cycles.